Hello, so today we are going to do this Leetcode day 29 from Leetcode 30-day challenge. The problem says, check if a string is a valid sequence from root to leaves, path in a binary tree. So we want to check if a string is a valid sequence from root to leaves, path in a binary tree. So given a binary tree where each path going from a root to any leaf forms a valid sequence, we want to check. So basically, if we have a binary tree and each path going from the root to any leaf forms a valid sequence, we want to check if a given string is a valid sequence. Okay, we get the given string from the concatenation of an array of integers and the concatenation of all values of the node along a path results in a sequence of, that's a little bit confusing. So we get the given tree by concatenating an array of integers and concatenating all the values of the node along a path results in a sequence in the given binary tree. So with this binary tree and this array, we want to get the path for that construct this array. So 0, 1, 0, 1, and we say true if we can find a path. Okay, so basically we have a binary tree and we want to check if the given string is a valid sequence, and the given string is represented by this array of integers. So for 0, 0, 1, well, we could go 0, 0, but then there is no 1, right? Here is 0, 1, 1, right? Okay. Okay, how can we solve this? So let's just try to write down what we know. So we have array sequence, right? Is it valid? This is what we want to know. Is it valid? And valid means there is a path in the binary tree for it as a sequence. Okay. So, well, we could just, so a path needs to be from the root to any other leaf. So, which means we could just go through, like, check if the left value is equal to the next value, and or if the right value is equal. If none of them is equal, we could just return false. But if left and right had the same value, we'll need to explore both, right? So if, which would be kind of hard to have, right? Because is it just 0 and 1s, right? Are the values just 0 and 1s? No, the values can be a lot between 0 and 9. So yeah, so the node values are between 0 and 9. So, well, we could maybe recurse, like think about, can we recurse? Which would mean that we would have to say maybe something like this, node left, if we say that this is node, for example. Let's call this node. And then do it for node right. And so what should be the array for a root that we pass, right? So if we have 0, 1, 0, then the first time, maybe 2, 3, 0, 5, something like this. So the root would be here. There is left. How can we distinguish left and right? It's a binary tree. So it's a binary tree, so left doesn't have to be smaller than the right. Okay, so we can't use that, right? The array actually is the path we have. So let's say this is something like this is the path. So we'll check if this is not equal to the root. So if path 0 different than node.val, we could just return false, right? Just return false. Now if the otherwise, that means it's equal, so we could explore this path on the left side, which means we could do, or we could explore it on the right side and do array 1, 2. So explore both sides and just return this or this, right? And then also if this is array, if the array is empty, well, so the array is empty, which means we reached a path, so we return true, right? I think this is pretty much it. Let's try it. So this is OR. We need to do self dot okay, I will also need to say if not node, and the array is not empty, return false, right? Because we didn't find it. Okay, so that's for the first example. Let's try with this example. Okay, let's try with this one too. That one seems good. Okay, the last one is wrong for some reason. The last one should have returned false, but for me it returned true. So it's 0, 1, 1, 0, 1, 1. Okay, so the path has to reach the end. So this shouldn't be enough. So what we should do is here, if not node, return if the array is empty. Length of array equal to 0, then we should return true. Otherwise, if not array, return false. Okay, that looks good. Can we just say it would be, well, we could just return leave it like that to be clear, to make the code more clearer. So we have a wrong answer here. So this is this tree 8, just 8, so just the root should return false because that's not. So why did it return true for me? Oh, because, well, it shouldn't be that. Oh, let's see. So 8, it doesn't, it does. Okay, so if it goes left, then if it goes left, then the array is empty, and that's not a node. If it goes right, sorry, then the array is empty, and that's not a node. Okay. Um, okay, maybe we need to do something different here. What could that be? If length of the array is equal to 1, then we should just return node val equal to array 0 and node.left doesn't exist, and node.right, it doesn't have any children, and that's a valid one. Now, if the array length is not 1, we don't need to check this. Don't think we need to check this anymore. Let's try this. Oh, not node. Okay. Okay, so that's accepted. Cool. So that handles the case, this case here, with the first check here. Cool. Yep. So pretty much it just recurs here on the left side and the right side, and do conditions that check that we have termination conditions basically. Yeah. So that's it pretty much for this problem.